So today our topic is going to be learning different ways of viewing percents. We've all grown up learning about percents in terms of multiplication, basically. Taking a look at an example like this, let's say that we were looking at a question like this, where someone were to ask us, what is 27% of 11? Now, whenever we approach a percent problem, there's a couple of ways we can break this down, and I want us to examine several different ways of doing this today. Practice a couple of these methods. Once again, you'll get fast at it. One of the best ways to approach percents, I've always found, is to break these things down into pieces. Remember, if we're taking 27% of something, that's the same thing as basically saying I need to take 20% of it plus 7% of it. So I need to take 20% of that 11 plus 7% of that 11. That might be an easier way of breaking this down. Depending on what we do, it can be a little more challenging at times, mostly because while 20% ought to be pretty easy to calculate, 7% could be a little bit more difficult. Whenever we're taking percents of any number, it's always best to work in groups of tens. That is to say 10%, 20%, 30%. Why would I say something like that? Well, think of it this way. Let's look at the number 37, for instance. And I just want to know what is 10% of this number. That's easy because I have an unseen decimal point right here. And whenever I want to take 10% of something, that means this. Take that decimal and move it one over to the left. So 10% of 37 is simply 3.7. All I need to do is look at it and I'm done. And I say to myself, well, hold on a second. If 10% simply moves the decimal one time, what would 1% be? 1% is 1/10 of 10%, so it accomplishes the same thing. It once again moves my decimal over. So 1% of 37 would be 0.37. What would, say, 0.1% of 37 be? Once again, we're just going to take our decimal, move it over, and the answer there would be 0.037. We can go on and on and on like this, but this is a good way of starting to break things down. So if somebody were to ask you, what is 20% of 37? Here's how I might approach that problem. I'd say, well, 10% of 37 is 3.7. Easy to calculate, all I do is move my decimal. And since 20 is twice 10, then if I want 20%, all I need to do is take double the 10% that I calculated. So what is 2 times 3.7? 2 times 3 is 6, and 2 times 0.7 is going to be 1.4. So I would come up with 7.4 as my answer. So 20% of 37 must be 7.4. See how we break it down into pieces right here? Always try your best to break it down in terms of 10% or 1%. The reason I say that is because those things are very easy to calculate. You don't really have to actually do any calculation at all. All you do is simply move the decimal points. Another way of viewing this, if somebody were to ask me this question, let's go back to our original example, break it down into 20% and 7% of 11. 10% of 11, 20% is 2 times 10%, remember? And 7% is 7 times 1%. So we need to identify these two percents. 10% and 1%. So what is 10% of 11? It's just 1.1. All I do is move my decimal over. What is 1% of 11? It's just 0.11. I move my decimal over twice. So let's do a little bit of arithmetic here. I need 2 times that 10%. Well, if 10% is 1.1, what is 2 times 1.1? Simple, 2.2. And what is 7 times 1%? Well, what's 7 times 0.11? That's easy, 0.77. So now I need to add these together, 2.2 plus 0.77. I start with my whole number of 2. I write a 2 in my decimal. 2 plus 7 is 9, and 0 plus 7 is 7. So therefore I conclude 27% of 11 is going to be 2.97. You starting to see the pattern here? Whenever we're trying to take more complicated looking percents, we can break this down into pieces by always falling back on groups of tens or ones, because those are easy to calculate. All we have to do is move a decimal and we're done. And it's easier to basically say, well, if I need 20% of something, let me just think of that as 2 10%. Let me think of my 7% as 7 1%. All of those make things much easier to work with. But now let's move on to my favorite way of calculating percents, and something that you probably haven't seen before. So let's clear these. So here's something going back to our original example right here of 27% of 11. Now, when you first learned about percents, you probably saw things structured this way. When somebody posed this question to you, they probably told you that this is what it means. It means to take 0.27 times 11. That's exactly true. That's the definition of a percent. That's what it means to take 27% of something. It means take 0.27 times 11 in this case. That's what it means to take 27% of something. So that's what you've been told. Here's what you probably have not been told, that percents are reversible. I'll say that one more time. Percents are reversible. What do I mean by reversible? I mean 27% of 11 is the exact same question. How do we write the same mathematically? We write equals. It is the exact same question as saying what is 11% of 27. We're going to examine why this is true here in just a second. But if these two questions are logically equivalent, then it doesn't matter which one of them I work. I'll get to the same answer either way. So would I rather calculate 27% of 11 or 11% of 27? This one is immediately looking easier to me. Why? Because 11 is just 10 plus 1. 10% plus 1% gives me 11%, and both of those percents are very easy to calculate. How do I calculate 10% of this? Easy. I just move my decimal over and I get 2.7. How do I calculate 1%? Easy. I just take my decimal and move it over and I get 0.27. Once again, when I add these, 2 plus 0 is just 2, write my decimal, 7 plus 2 is 9, and 0 plus 7 is 7. Amazingly, I came to the same answer that I did previously, and I did it by working this different problem right here. So this gave me the same answer as asking this question. So let's ask ourselves, well, why is this true? How does this work, basically? Let's take a look at something like this. Let's say that I want to just calculate, let's take more of a look fundamentally from this example, and I want to calculate 27% of 11. Well, the definition of a percent means take this percent, convert it to a decimal, and simply multiply the two. So now I am multiplying 0.27 times 11. That makes sense. 0.27, however, let's take a closer look at that right there. What is 0.27? Remember how when we first learned decimals, we learned this is the tenths place and this is what we call the hundredths place. The reason for that is I could think of this 0.27 as taking 27 times 0.01. That is to say, dividing it by 100. If I were to multiply 27 times 0.01, that's exactly what's going to give me my 0.27 here. Think of it this way. What if I had 27 divided by 100? How would I write that as a decimal? I would write it as 27 hundredths. That's exactly what this means. So this could be thought of 27 divided by 100 could be thought of as 27 times 1 over 100. Let's take a look at this and this right here, and we'll see that they're logically equivalent. taking 27 divided by 100, that would be the same thing as taking 27 times 1 divided by 100. 27 times 1 is 27, 1 times 100 is 100, and it still ends up with this fraction right here. So if this is true right here, this 0.27 really can be thought of as something like this, then I can rewrite this line right here as follows. I can say, well, that's 27 times 1 over 100 times 11. But wait 1 second here. Now I have nothing but multiplication in my expression here. What do we know about multiplication? It's commutative. Multiplication follows the commutative property, which means the order doesn't matter. I can do this in any order I like. I can rearrange these terms entirely as I wish, and I will get the same result either way. So if I desired, I could say, well, wait, 1 over 100 times 11, I could rewrite this as 0.11, because 1 over 100 times 11 is 0.11. And once again, I follow that a step in reverse further, just like I did here. I say 0.27 is 27%. That means 0.11 is 11%. So I could think of this as 27 times 11%. In other words, I'm asking 11% of 27, and we see how this falls through. So basically, whenever you are asked any question like this, what is this percent of this number right here? You can also take this percent of that number right there, and you will get the same answer either way. So here's what you ought to be asking yourself. If this is the original question, is that easier to work, or would this percent of that number be easier to work? Either way is fine. Either way gets you the same answer. So see which one is easier for you to work, and then you're home free. Let's practice with a couple of examples here. What if I wanted, say, 34% of 75? That seems like a hard problem to work, but I recognize, well, this is logically equivalent to taking 75% of 34. Taking 75%, what's the fraction for 75%? You remember correctly, that's 3/4. So this is the same thing as simply taking 3/4 of 34 right here. I can cross cancel some of these because both of these are divisible by 2. 34 divided by 2 is going to be 17. So I really have 3 over 2 times 17. Let's break this down into 2 pieces. What's 3 times 17? Well, 3 times 10 is 30. 3 times 7 is 21. 21 plus 30 is 51. 2 times 1 is 2. So I have 51 divided by 2. 50 divided by 2 is 25. Very good. And 1 divided by 2, well, is 1 divided by 2, 0.5. So my conclusion is that 34% of 75 is going to be 25.5. Let's double check ourselves just to make sure we're right. So if I were to take 0.34 times 75, lo and behold, it does indeed give me 25.5. What a coincidence. Let's take a look at another example here. What if I had 63% of 99? I admit that sounds like kind of a hard problem to work, but then I could recognize, well, wait, that's just 99% of 63. Wait, doesn't this seem just as difficult to work? I say at a glance, yet, but if we stop and think about it a little, then maybe not so much. 99% is so close to what? You guessed it, 100%. It's so close to just being 63. In fact, it's only 1% less. Well, what is 1% of 63? All we need to do is move the decimal over. So it's basically going to be 100% of 63, which is 63, minus 1% of 63, which is 0.63. Okay, well, that looks like a complicated subtraction problem. Once again, there's no need to make it complicated. Let's think about it. I'm at 63 and I'm taking some away, not even a whole, so that means my whole number is going to be 62. I can go ahead and write that. 3 minus 0.63. Well, 3 minus 0.6, think of what would 30 minus 6 be? 24. Now just put your decimal right back in the middle, 2.4. So 3 minus 0.6, 2.4. Subtract off 0.03 more, and we have 2.37. Very good. So we have 62.37, and we're done. Let's look at one more example. 46% of 51. Of course, yes, we could also ask ourselves, what is 51% of 46? And once again, we're going to be getting the same answer. Well, 51% is just 50%, which is half of something, plus 1%, which is easy to calculate. So what is half of 46? Easy, 23. What is 1% of 46? Just move my decimal over 2 to the left, and I have 23.46. You see how fast that was without a calculator, without even having to write things down, how easily we broke that down into pieces. Sometimes it seems like this stuff is too easy, but it could be that easy. Give this stuff some practice. You can actually have some fun with this. Keep on coming up with new examples in your mind and constantly working ways to break it down into easier pieces to work with. Remember, problems are only as hard as we allow them to be. Usually speaking, if we stop and think about it, there are much, much easier ways to work things.